Hey guys, today's lesson is going to be on finding slope and rate of change. It is a very important concept in algebra and in upper level math, so please make sure that you pay close attention. To start with, I'm going to show you a video that I found. Notice that on that page, and when I go back to it, you'll see it, I gave full credit for the person who came up with this video. You need to do that for copyright laws and just because it's polite.
Rise up or run out. We mapping graphs to the triple R sound. We're talking points and slopes, axes and origins, y-intercepts and quadrants, all four of them. Rise up, run out. We mapping graphs to the triple R sound. We talking points and slopes, axes and origins, y-intercepts and quadrants, all four of them. The four quadrants start from the top and right, counterclockwise from the positive x and y. You go around, hit the 2 and then 3, bottom left negative. Remember that, please. If you got a single point on the x-y grid, there's a single pair of values telling you where it is. This x coordinate goes from side to side. The y follows a comma to define the points high. A straight line between 2 points is a relation. You can represent it with a linear equation. Y equals m times x plus b. If you wanna know the variables, listen to me. M is the slope, that's rise over run. It tells you how steep the line is gonna become. B is the intercept, that's how you assess the point at which the line goes through the y-axis. Rise up or run out. We mapping graphs to the triple R sound. We're talking points and slopes, axes and origins, y-intercepts and quadrants, all four of them. Rise up, run out. We mapping graphs to the triple R sound. We talking points and slopes, axes and origins, y-intercepts and quadrants, all four of them. Say you got a job and you're earning your pay. You start with 50 bucks and get 9 every day. If you wanna know over a year how much you get, calculating the graph might be your best bet. On the X, you're measuring one day at a time, and your money gets tracked on the vertical Y. Now you got some, and you ain't even worked yet. 50 bucks, put it up, that's your y-intercept. After the first day you got 59, now you got 2 points, you can start drawing a line. The slope of that line, remember, rise over run. It's dollars over days and you got 9 over 1. Remember B, I think that's where we started at. $50 up on the graph, the y-intercept. And you know y equals mx plus b. Now you got y equals 9x plus 50. Rise up or run out. We mapping graphs to the triple R sound. We're talking points and slopes, axes and origins, y-intercepts and quadrants, all four of them. Rise up, run out. We mapping graphs to the triple R sound. We talking points and slopes, axes and origins, y-intercepts and quadrants, all four of them. Rise up. Rise up.
Okay, hope you enjoyed that video. Make sure, again, that you give credit to people when you borrow their things. Okay, the vocabulary you need to know. Okay, today we're going to talk about finding slope of a line. So first, we need to define slope. Slope, basically, when given 2 points on a line, it's the ratio between the rise over the run. The rise is the change in y, and the run is the change in x. There's several ways we can write this. We can write it out in words: rise over run, change in y, change in x. This is the mathematical way to write it. Remember, M stands for slope. This are the y coordinates for the second point minus the first point. This is the x coordinates for the second point minus the first point. In class, you will hear me say all the time the expression, y is it over x? I do that to help just remind you that you're putting the differences of the y's over the differences of the x. This is a very common mistake, is to flip that upside down. If you flip that upside down, unfortunately, your slope is incorrect. Now, mathematically, if I'm going to put y over x, I need to put this symbol. It looks like a triangle. It's called delta. Delta y means the difference of the y's over, that's a triangle, delta x, difference of the x's. So mathematically, this is the way you're going to see me write it all the time. And then graphically, what we're looking at is between any 2 points, I'm looking at the ratio of the rise, how far do I have to get up or go up, over the run, how far do I have to go over to get from one point on the line to the next point on the line. What is really cool about slope and lines is I can pick any 2 points on the line and the slope is going to be the same. So if I know the slope and I know a point on the line, I can find another point. So if I go from this point to this point, the rise over the run is going to be exactly the same as this rise over this run. When you reduce those fractions, you'll see that they create equivalent fractions. Okay, so our first example, we need to find the slope of this line. So I have 2 points. Something that you'll see me do a lot in class, I will label the points. I have x and y, x and y. I do that so that I don't accidentally make any kind of silly mistakes, because it's very easy to make silly mistakes. Some of you may be wondering, well, which point do I use first? Well, I wonder if it matters if I use the first point first, if the slope will be different than if I use the second point first. Well, we're going to look at it and discover the answer together. So I'm going to use this point first. I'm going to do the difference of the y's. So I have 2 minus 5 over the difference of the x's. Now the key here is when you start with this point with the y's, you have to start with that same point for the x's. So now I have 2 minus 5, that gives us a -3. If you have trouble with that, use your calculator. -1 minus 3 gives me -4. When I simplify this, a negative on top, a negative on bottom becomes positive. So my slope is 3/4. Okay, now we're going to explore, what if I did it the other way? Am I going to get the same answer? What do you think? Okay, I'm going to start here. The difference of my y's. So I'm going to do 5 minus 2, the difference of my x's. 3 minus -1. Minus a negative, remember, is same thing as a plus, so that's 3 plus 1, 4. Notice, my slopes are the same. So answer the question, does it matter which point you start from? The answer is no, as long as whichever point you start from the y, you do the same order for the x. Also notice that this slope is positive. Notice looking left to right on my graph that the slope is going up. I always think of it as an airplane taking off. So my airplane's taking off. I'm going to grandma's house. That's a very good thing. It's a positive event. So this is a positive slope. Okay, let's look at this one. I want to find the slope of this line. Now I want you to look at this line. Looking left to right, it looks like, pretend that's a plane, it's going down. So this is like, I have my plane and it's falling to the ground. What kind of a slope do you think that is? Well, let's figure it out. So here's my xy. Remember, I label just because it helps me not make mistakes. So I'm going to do the difference of the y's, difference of the x's. The order does not matter. I'm just going to go that way this time. Notice I have minus a -2 because minus is in the formula for slope. I must put it. 2 minuses really make that plus. 1 minus 3 makes that a -2. When I reduce this, I get -3. So my slope is -3. Notice with the negative slope, when I go left to right, it looks like my plane is crashing to the ground. That would be a very negative event. So my slope is negative. Okay, pause to do your checkpoints, play to look at the answers. Okay, Obviously on this one, my airplane must be taking off, a very positive event. I'm going to grandma's house. This one, my plane must be crashing to the ground, a very negative event, something I really don't ever want to experience in my life. Negative event, negative slope. Okay, we want to find the slope of this line. Notice this line is what kind of a line? Horizontal. Can you tell me the equation of this line? Every horizontal line has the same type of equation. It is y is equal to some number. That number is where it crosses the y-axis, and that is 5. So if you said y is equal to 5, you're correct. That is the equation of this horizontal line. Okay, I want to figure out what is its slope. And my other question to you would be, do you think the slope of every horizontal line would be the same? So I'm going to do the difference of my x's over the difference of my y's. And I said it wrong. Difference of my y's over difference of my x's. Okay, so y is it over x? So make sure you're always thinking, am I doing the formula correct? Because it's very easy to say it wrong, very easy to do it wrong. So I always write it, recheck it. Notice how I do my arrows. The y's on top, the x is on bottom. It's a visual to help me remember y over x. Okay, so I have 5 minus 5 is 0. And 2 minus a negative 4 is 2 plus 4, which is 6. So this slope turns out to be 0. 0 divided by 6 is 0. Check it on your calculator if you don't believe me. So this slope is 0. And I will tell you that the slope of every horizontal line is 0. If you think about your airplane scenario again. So here I have my airplane flying. I'm up in the air and I'm just flying. And what's happening? Absolutely nothing. Nothing is happening. It's not exciting. I'm just flying straight across. So my event is 0. My slope is 0. Nothing is actually happening. Okay, here I have a vertical line. Tell me the equation of the vertical line. Well, remember, every vertical line has x equal to some number. That number is where does it cross the x-axis? You can tell it from the points. X is equal to 4 is the equation of that line. Okay, we want to find the slope of the vertical line. I want you to right now think about what you think that might be. Just guess. Okay, so my slope will be difference of my y's over the difference of my x's. Y is it over x? So label my x's and y's. The more I do, the less likely it is I'm going to make a mistake. It doesn't matter which order I go, so let me go the other way. 3 minus a negative 2 over, remember, where you start with your y, you have to start with your x. 4 minus 4. 2 negatives there make a positive. This is really 5. 4 minus 4 is 0. Okay, so I'm asking, what is 5 divided by 0? Tell me. Okay, if you say 0, I need you to get a calculator and plug it in. 5 divided by 0. That should give you an error on your calculator. We cannot divide anything by 0. So this is undefined. This is undefined. My slope for every vertical line is undefined. So we go back to our plane scenario. What are we thinking about? That plane's really bad. Okay, so I'm in my plane and basically it is crashing straight down to the ground. Okay, so a couple of ways to think about this. We can think about the slope is changing so quickly that I can't define it, undefined. The other way to remember it is if this was happening to you, you would probably say something that wasn't so nice that we can't say on this video. So a lot of mathematicians say that the word undefined is kind of like mathematics, little 4-letter word. Okay, so undefined, I'm crashing to the ground. That's not very fun. And, you know, most people in a panic maybe would say things that they wouldn't say otherwise. So our little 4-letter word, undefined. Okay, so crashing to the ground, slope's changing so fast. Don't know what's happening, undefined. So checkpoints, pause, Play for the answers. Okay, it looks like here we found an undefined slope. So that was a vertical line. So I'm crashing so quickly that I can't figure out what this slope is. Oh my goodness. Okay, this one had a slope of 0. That means it's horizontal. That means we're going to grandma's house and nothing's happening. We're just flying straight. We're just in the process of going. Okay, finding a rate of change. Okay, rate of change is just a different way to say slope. I don't want you to get confused when you have to take these concepts and apply them to word problems. Okay, they are not going to say find the slope in a word problem. They're going to say rate of change. So rate of change is just a fancy way of saying slope. You find the slope and then you convert it to something usable in the word problem, which is a unit rate. You should have learned how to do a unit rate in 7th and 8th grade math. Basically, that's when you divide your number so that your denominator was 1. So we have a table. We love tables in algebra. You'll see tables all the time. We're comparing the cost of gas for a number of days. And we want to find the rate of change. So that's your key for slope, changing it to a unit rate with respect to time. This is key. This is a key concept, with respect to time. When you see the words with respect to something, whatever that something is, that's telling you what the independent variable is. And remember, the independent variable is the x. So they're telling you that time is your x value, which would mean the price is my y. Okay, so I have to know what's the time so that I can push out my dependent variable, how much it's going to cost. Now, tables, you cannot assume that the top or the left is your x and the bottom or the right is your y. It doesn't work like that unless they label it that way. So you're going to have to figure out what's my independent variable, what's my dependent variable. If they say with respect to time, they've just told you independent or x. Okay? Now, don't let the table confuse you either. A table with 2 pieces of data, time versus price, is just a fancy way of doing ordered pairs. Here's an ordered pair. 1, 1.99. Here's an ordered pair. 3, 2.09. 5, 2.19. These are just ordered pairs, our x's and our y's. Okay, so to find the rate of change, I'm going to do cost over time. Remember, y is it over x? We're just finding slope. So to find slope, we take 2 points. Let's take the first 2 points, and we're going to subtract them. Difference of my y's, and in the same order, difference of my x's. 3 minus 1. When I simplify this, I get 0.1 over 2. Okay, and then I need to actually do the conversion to the unit rate. I do that by dividing. So on your calculator, you could do 0.1 divided by 2. If you're doing it by hand, it would be 0.1 divided by 2. Okay, when you do that, you end up with 0.05. So you're going to get 0.05. And of course, unit rate means the bottom is 1. So now we have to take this answer and convert it into something that's usable that anybody could understand. What does this mean? This means, remember that the top was price, it's the y. So this is $0.05, which is really 5 cents. The bottom is x, which is our time. This was days. So the rate of change in price is 5 cents per day. As simple as that. Okay, so do not let application of slope confuse you. Okay, check points, pause, and then play for the answer. Okay, when you did this one, did you notice, first of all, that they asked you for the rate of change? Remember, that's a fancy way of saying slope, and then just converting it to a unit rate because it's a word problem. And then they said with respect to time. Time is our x. Notice in the chart, time is not on the left. So the left is not the x. This is actually the y. The time is x. Okay, so we pick 2 points. Remember, these are ordered pairs, except they're backwards, aren't they? Okay, so if I was actually creating this table, I would have switched the time and the temperature so that the x would be on the left and the y would be on the right. So just be careful about that. So we're going to do our slope. It's the difference of the y's. So take 2 of the y's and subtract them. And then in the same order, take your x's and subtract them. Okay? And it looks like you're going to get 5 over 2. Convert that to your unit rate by dividing. You're going to get 2.5 over 1. Okay, remember the top is it's y over x. So the y is temperature and the bottom is time. So 2.5 degrees Fahrenheit per hour. Okay, so basically we've learned about slope and its formula. The technical formula is the difference of the y's over the difference of the x's. Delta y, delta x. Remember, if the slope looking left to right is going up like the plane, it's a positive slope. Looking at it left to right, if it's going down, that's a negative slope. If it's horizontal, I'm flying, nothing's happening, my slope is 0. And if I'm crashing to the ground, I'm saying some things that aren't very nice, and in math, that is called undefined. Rate of change is just a unit rate of slope. With respect is the x. Find your slope, change it to the unit rate by dividing. Okay, if you need more information, make sure to read section 4.4 in your textbook or look at these other links. I also would tell you to go back to the beginning of this video and re-look at that video that I pulled from YouTube. It will probably make more sense to you. See you later.